Good morning. I am going to explain my first C project. The name of the project is LSB steganography. Before going too deep inside the technical term of this project, first I want to explain few terms related to the steganography for the better understanding of this project. In introduction, we will see first what is the steganography. So basically the steganography is the practice of concealing file, message, image or video within another file, message, video or image. Why the steganography is necessary or where it is used? So mainly the steganography is used to hide secret credentials, datas, or to detect the data forgery or passing a message in secret. So where it is used? It is used in the military intelligence agency, elections, internet banking, and medical imaging. So there are many methods of doing steganography. In ancient time, there are many methods like inside the drawing, paintings, and many more methods where people are hiding the data. But here now what we are going to use is the digital steganography. So digital steganography has many types like text steganography, image steganography, audio steganography, video steganography, and network steganography. Here we will use image. So what is the digital steganography? Here mainly inside any digital data, it can be text, image, audio, or any kind of file. We will hide our own secret message. We will send it, and the person where the data is sent, he will be able to decode the secret message from that digital file. Here in our project, we will use image file. So inside that image we will use .bmp file because it is uncompressed and easy to edit because of its format. So before going too deep into this, first understand what is the image file. So image file is a file which contains a picture elements called pixel, or in other word, you have also heard the smallest unit of a image is called the pixels. A image contain a pixel in fixed number of rows and columns. This all pictures are grouped along with different information to form a format which is differ for each file format. It can be .jpg file, .bmp file, or any other image file formats. What is the pixel? So basically pixel represent two things. First is the color composition, second the intensity. So intensity of each pixel is going to vary for each type of image. Similarly, the color imaging system of each pixel is different. Typically, it can be represented by 3 or 4 intensities, such as the RGB represented by the 3 intensities RGB, which is stand for red, green, and blue. Similarly, there is another method of representing the pixel. It's called CYAN, and another is CMYK. All this represents one color of a pixel. Image formats, how a image file format looks like. So image file formats are a standard way of organizing these RGB files, or this is pixels, along with the datas. So image files are composed of digital data in a format that we use to display a image on our computer display or a printer anywhere. So digital file may be compressed, uncompressed, or vector format, but one is rasterized. A image become a grid of pixel, and each of has a number of bit and its color equal to the depth of the device displaying. So how does the BMP file formats look like? Because the image file can be of many type. It can be .jpg, .bmp. So here in this project we are using a BMP file. So how the BMP file formats look like? So first, what is the BMP? BMP is like window bitmap. It is a type of image file which handles graphic files within Microsoft Windows OS. Typically it is uncompressed, therefore it is large and lossless. Compared to JPG, it is a compressed type of image file. So advantage of BMP is very simple, that it is a very general and simple structure and wide acceptance in the Windows. So in this slide you can see how a BMP file formats look like. First it has a header byte, after that RGB data, after that ind-of file. So in BMP file format, first 54 byte of data is called the header data. After that they will store each and every pixel data, which is called the RGB data. Here pixel is RGB, it can be CYAN or CMYK, it depends. So here it is a RGB data format. So we all each pixels have three data like R, G and B. So it can be red, green or blue. So all this data or all these pixel are arranged after the header file. After this RGB data there will be the end of file. So the first 54 byte of a BMP file, it has their own format or structure which is represented in this slide. Like different color is representing different type of data which is inside the header byte. So it is a image magic signature, size of the file, reserved, file offset, raster data, bitmap width, bitmap height, number of planes, bits per pixel, compression type. So all these datas are inside the first 54 byte, which is called the header byte of .bmp file. After that the RGB data will come. So in RGB file format you can see the three colors mainly denoted by RGB: red, green and blue. So all the data of RGB is a byte of data, so it has 8 bits. So all are arranged in a form to make a file format, image file format. After that, here in this project we are using LSB steganography. So why we are using a LSB steganography? We can have other changing bits also. Why we are just changing the LSB bit? We can change MSB bit also, we can change other bits of the RGB data also, but we are just changing the LSB bit of the each byte. So the reason of changing LSB bit is very simple. See, here on the screen you can see that there is a image of red block BMP file, and we will try to change the MSB byte of this pixel, and we will see the effect. What happens if we change the MSB of a BMP file RGB data? So if you can see, after changing the MSB, there is a huge difference in the color or the pixel. So this pixel was representing the red color, but after changing the MSB bit, just one bit, the impact is very huge, the whole color changed. So if you try to hide any data in the MSB bit, the output will be not same as the input. The image color, maybe format or anything, it will change. So if you will try to hide data in the MSB, it will be observable that you have changed the image. So maybe some data has inside this image. So rather than MSB, we will go for LSB, because now if we change the LSB bit of this BMP file, this color will not change. It will be same like it is showing on the display. So that's why we are using the LSB. So the main reason of using the LSB steganography is that even if you change the LSB bit of a RGB pixel, the output will not change. It will look exactly same. If you can see the difference, it means you have a superhero eyes. But for a human being, it is not visible. Yeah, the MSB bit is changed, but the output image will not seem very different from the last image. So this is the main reason we are changing the LSB bit of the RGB data. So now come to what we are doing in this project. So in this project summary, what we are going to do is we will take one .bmp file. Inside that BMP file, we will put a secret data, whichever we want to send it. After putting that secret data inside the .bmp file, we will send it to the destination, and after that it will be decoded what the secret data is hidden inside that image. And while doing this project, first thing we will keep in mind that image should not be changed. The output image, after encoding our secret code, it look exactly same as the input image. So after encoding our secret code, it should not harm the .bmp file or image file. So in this project we will encode a message. After that we will decode the secret message which is already encoded inside the image. First understand how we are encoding this message inside the .bmp file or any image file. Since here our file represented by the RGB pixel, so each pixel will consist of three parts, R, G and B. So what we will do is we will take each part of the pixel and we will update each bit of our secret data to the LSB of that pixel byte. So for example, we will take so to understand it with example, we will take one message. For example, our message we want to hide inside the image is 01000010. So what I want to do is I want to hide this message inside that image, and then again I want to decode that message from the output image. So what I will do, I will take the RGB data. We are not going to change the header file. First thing you have to understand and keep that in mind, the header file is a format. So we can't change that 54 header bytes. So we will just skip the 54 bytes. After that, I will do all my operations on the RGB data. So the file format will not be disturbed. So for that, first I will skip all 54 bytes of the header file. After that, I will encode my message in the RGB data. So here our pixel is represented by RGB. It is not going to same for every images. It can be CYAN, it can be CYMC. So keep that in mind. The pixel will consist of that number of colors, whether it is represented by RGB, CMYC or CYAN. So according to that, we will put our message. So in this example, I am taking a pixel of RGB and my message is just a length of 8 bit or 1 byte. So for example, I want to hide a 8 bit of message. I need 3 pixels at least, because here 1 pixel is consist of RGB means 3. So in order to hide 8 bits, I need at least 8 data of 8 byte of data. So 3 pixels is equal to 9 byte of data. So at least we will take 3 pixels. After that, we will encode each byte inside each pixel, and then we will decode it from the output image. So here what we will do, we will perform the OR operation. To set a bit, we perform OR operation. To remove a bit, we perform complement of AND operation. So here in this, I will take each bit of data from our message. So we can either move from left to right, means we can move from LSB to MSB, or we can move from MSB to LSB. It is not going to make any difference, because the way you will encode the data is the same way you will decode the data. Here what I am doing, I am going from MSB to LSB. So first I will encode my MSB bit, then in the end I will encode my LSB bit. So for that we will keep this thing in mind. It is not necessary that the encoding method is going to be same for everyone. Here in this project I am using MSB to LSB bit, but you can also use LSB to MSB bit. But you have to keep that thing in mind, that how you are encoding this data, because the same way you are going to decode this data. So here in this example our message is very crystal clear. It has just 8 bit or 1 byte, which is 01000010. We will take one pixel. It has three part, red, green and blue. So first 3 byte will go to the first pixel, next 3 byte will go to the second pixel, and the last 2 byte will go to the third pixel. So RGB represent means first byte will be R, second will be G and the last will be blue, red, green and blue. So in the red, my first bit will go. To append this bit, we will use OR function or bitwise operator. To take the data, to read the data, we will use the AND operation. So in order to encode my message, we have to use these operators. So after encoding the data, my output will look like this, because all the LSB bit of the RGB bytes will now filled with our data. So whenever you want to decode this data, what we will do is we will read the LSB bit of every byte of the message. So when I am going to decode this message, what I will do, I will take one byte from the file. I will read the LSB bit of each and every byte of RGB data. This is how we will decode our message. So before going to this flow chart of how we are encoding and how we are decoding, first thing I want to tell you that you have to understand we are not directly taking the byte from the start of the file, because first 54 byte is header file. So in order to not disturb the format of any file, we should not touch the first 54 header byte, because it is storing some data related to our file format. So we will skip this much of data and we will just update the LSB of RGB data. So first 54 bytes of the header will be skipped from us. We are not going to change, we are not going to do any change in this 54 byte of header. So we will skip, or in other word, we will copy is at it is to our output BMP file. So in this project, what we are mainly doing is we will read first 54 byte of a .bmp file, which is our input file, and we will copy it as it is to our output file. So all 54 header byte will be going to copy as it is to the output file. After that, when the RGB data is started, what we will do, we will read one byte from the file, and then we will change the LSB bit of that byte with our data. So as I told in the example, for example, if I am trying to hide a character, so let's our character is A, so it must be represented by 1 byte or 8 bit. So all the bit is going to be in the LSB of the each byte of the RGB data. So I hope this example is enough to understand how we are encoding the message and how we are decoding the message. So each pixel have the 3 bytes, which is R, G and B, and inside each pixel's byte, what we will do, we will just update the LSB with our bit of the message. It can be done from MSB to LSB, it can be done from LSB to MSB. It's totally depend on the person who is writing the code for encoding, but just he have to keep this in mind. The way you will encode the message is the same way you are going to decode the message. So the flow chart of encoding will look like this. We will start with two options, that the user want to encode the data or user want to decode the data. So if he is encoding the data, he will pass -e to encode the data, and if he is decoding the data, he will pass the option -d to decode the data. So the flow chart goes like this. We will start, if the option is -e, we will understand, okay, he wants to decode encode the data. So we will ask user pass the file. So if file is .bmp file, then we will proceed to the next step. Otherwise, we will print the error message and stop the execution. If it is .bmp file, we will check the secret file is provided or not. If secret file is not provided, we will print error message and we will stop. If the secret file is provided, we will calculate the size of a secret file. Because since our RGB data we are editing, if it is not long enough to encode each bit of our data, then we are not be able to encode our message inside that image. So we have to make sure that the size of image should be more than the size of our secret data, because we can only encode the number of bits in a secret, in a BMP file, if it has more number of bytes than the bits in our secret data, because each byte is needed for each bit of the secret data. So it should be very very large than the secret message. So for that we will check, we will calculate the size of a secret file. After that we will see if the secret message is going to fit inside the BMP file or not. If secret message is going to fit inside, then we will proceed for the next step, or otherwise we will print the error message that the size of your secret message is going beyond the .bmp file size. So if the secret message size fit, we will go for the we will go for the .bmp file. After that we will again check the secret file is empty or not. If secret file is empty, we will again print the error message, and we will check the output file name is provided or not. Like for example, if I am going for abc.bmp as an input file, where the output file will be saved. So it can either enter by the user or it can be some default name. So if user is entering the name, then output image should stored inside that .bmp file. If it is not, then we have a default name, and the default name in this project we are using is .bmp file, output.bmp file. So if user will enter the name, that will go like xyz.bmp file. If user is not entering the name, then we will use the default name as a output file. So if user provided the output file name, then we will consider it as a name of the output file. If it is not, then we will use our default name. In this project I am using output.bmp file. So if output file is provided, then it's good. If it is not provided, then we will create a default. After that we will jump to C. Art option is provided. Here we are using that it has provided magic string or not. So if user has provided magic string, then we will encode that first before encoding our message. But the here main question come inside our mind is, what is the magic string and why we are using the magic string. So inside this project, the magic string play a very vital role to hide or conceal our data. See, if we know that first 54 is a header file, and we started our encoding part from the first byte of the RGB data, then the problem we will face is that if the encoding someone know, then he can decode. But even after someone know the method of encoding and decoding, and he don't know from where we have to start the decoding, it's hard for them to find our data. So if we will put some string data, like we are putting here a magic string, let's call I am putting the magic string as a 1 2 at the, yeah, at and hash. So at and hash and 1 2, so this 4 byte of data is equal to 32 bits. So first 32 byte of a RGB file with will be filled with the data of 1 2 at and hash. So only the person who knows the magic string will only know that after how many byte we are going to decode the real message. So it help us to conceal our data way a bit more secure, we can say, because magic string, see, steganography is not the best method to hide our data. Obviously if someone knows, they can decode our data, but magic string help us make it more secure, because if he don't know the magic string, the data he will decode will not be is not going to be the real data. So the magic string help us to make it more secure. So we will see that magic string is user input, or we have to use the default magic string. So after checking all the cases before, like it is a .bmp file or not, they are providing secret files or not, secret file is empty or not, if secret file is not empty, then we will check the file of secret size. After that we will check the size of .bmp file. We have to make sure that the size of .bmp file is enough to take all the data from secret file. After checking all this, we will ask user to input the magic string. If the user is not inputting the magic string, we will use the default magic string. So if user is giving you the magic string. So we will check what is the size of magic string, because again the magic string is going to encode inside our .bmp file, so it should have enough byte to encode that message according along with our secret file. So in this in this point of flowchart, we can see that user has option that he want to give us a user defined magic string or the default one. So here we will provide one option that he wants to give us a magic string, or we can use the default one. If he is going for the default one, we will set the default magic string, we will encode that magic string, and after that we will encode our secret txt, and then we will stop our execution. But if it is not the default magic string, then user will enter a string, and it can be of any length. So we will check the length of the user string, then we will calculate the size. Again we will check that the size of magic string plus the size of our secret data. If it is less than the size of .bmp file, then we will encode the magic string, then we will encode our secret message. After that we will encode input file extension and copy the remaining byte of bmp file. It means the all remaining bytes, like if our rgb data is 200 bytes and our secret message is not that long, so maybe after 10-20 bytes our secret message already encoded, so we will copy all the remaining bytes to the output file as it is, and then we will stop our execution. So once more I am going to explain this in detail, what are the steps we are taking and how we are doing it. First we will give a option to user, he want to encode the message or decode the message. If he want to encode the message, he will pass the option -e. If he want to decode the message, he will pass the option -d. After that we will check the input file is bmp or not, secret file is provided or not. After that we will calculate the size of secret file, and we will see that it is going to be fit inside bmp file or not. If not, we will pass the error message. If if not if it is going to fit inside, then we will go and check secret file is empty or not. Again we will check secret file is not empty, then only we are going to process to the next step. In next step we will see the output file name is given by user or we are going to use default. If it is provided by the user, we will use the same name to create the output.bmp file where the secret text is hidden. Otherwise we will use our default name, which is output.bmp in this case. After that again we will use one more string which is called the magic string. I already told the why magic string is needed, because it's help us hide the data more securely. It make it happen like it is more secure. Even if you decode the data without magic string, you have a not right data. So even if you get the data, it will be corrupted data, not the real data which is hidden inside the image. So it helps. So that's why we are asking user, he want a default magic string signature or he want to enter his own. So if user want to enter his own magic string data, then we will ask user to enter the string, then we will calculate the size, and we will see if it is going to fit. If it is going to fit, then we will encode the magic string size, magic string data, and after that we will put the extension. After that we will encode the message, and all the remaining byte is going to copy as it is to the output file. If magic string is not provided by the user, we will use our default magic string. So the main thing here what we are encoding rather than that checking part is that secret message, secret magic string, the size of magic string, the data of the secret.txt, file extension of the input file, then we will encode the secret message and copy the remaining byte as it is to the output file. So in the decoding part, we will see the option is passed as -d. So if it is a -d, we will check the input file is .bmp or not. And again, we will check the name of the output file is provided or not. If it is provided, we will use the same name for the output file. If it is not provided, we will use the default name. Here the default name is output.txt, because what we are hidden here is the txt data, secret.txt. So output data should be a txt file because the hidden data is the txt. So our default name is output.txt. If all these three conditions are met, then we can start the decryption of the data, and then we will stop the execution of the project. So the conclusion from this project is that hiding a data using LSB steganography is a good option because it is reduces the chances of being detected. But one of the disadvantage of this method is you need more number of pixels if data is too big. Because see, every time we are checking the size of .bmp file is enough or not to store our secret data. Because one byte can just hide our one bit of data. So it is almost 8 times greater. So if the size is not almost 8 times of our secret size, so it is not going to work. At least. This is not the exact calculation. So you can see this is the difference of 8 times in the input file and the secret.txt. So if we have too big data to hide, our main disadvantage is we need an image with more pixels. I hope this will be all about the explanation of LSB steganography. Now come to the part where I will show you how this is working. So for that, I will show you the codes, how we are executing it, what is the error message printing, and every other things. So let's see that.